Welcome to Wizznotes.com Mathematics Video Tutorials.
Question 9b says Juliet got $560 from her father for her birthday. She went shopping and found that earrings and bracelets cost $70 each. Juliet wants to buy X earrings and Y bracelets. She wants more than one, but no more than 4 bracelets. She also wishes to buy at least 3 earrings. First, we have to represent the above information by writing 3 inequalities in X and Y. We have to draw a graph of the inequalities using a scale of 2 centimeters to represent 1 unit on both axes. We have to indicate on our graph the region that satisfies the 3 inequalities. We have to determine the highest possible value of X and the corresponding value of Y, and then we have to determine the values of X and Y, which will give the minimum amount spent, and we have to determine this minimum amount. Now, this is a linear programming question because, as we can read, we have limitations and constraints on how Juliet can purchase her earrings and bracelets, limitations on how she can spend her $560. So this is a linear programming question. Right, so first we're gonna go ahead and put some information in that we have about X and Y. Right, and what we have so far is that X is a number of earrings and they cost $70 each, and Y is a number of bracelets costing $70 each. Now Juliet only has $560 to spend. We need to find now 3 inequalities from the information, and we note initially now first up is that she has $560 to spend on her earrings and bracelets. So therefore we know she cannot spend more than $560. She can spend less than $560, or she can spend the $560 but not more. So the total amount of money that she will spend, which will add up to the money she's spending on the earrings plus the money she's spending on the bracelets, will have to be less than or equal to $560. So let's put a statement in for us to see exactly what we're saying. So what we're saying is that Juliet can only spend $560 or less, and she's gonna spend on earrings. She's gonna spend $70 multiplied by X, 70x, and she's on braces. She's gonna spend $70 multiplied by Y. Right? So if we put in that equation, or that inequality, what we will have is that the total money she's spending is less than or equal to $560. That is $70 times X plus $70 times Y will have to be less than or equal to $560 because she cannot spend more than $560. And then if we divide through this inequality by $70, by the $70, we end up with our first inequality, and that is our first inequality. X plus Y is less than or equal to 8. That's our first inequality. Now for our second inequality, let's say we have to write 3. We read along and we see where she wants to buy, she wants more than 1 but no more than 4. This means she has to buy more than 1, so she can buy 2 or 3 or 4, but she cannot buy more than 4. Right, so she has to buy more than 1, but she has to buy less than or equal to 4. So let's put that information in so we can look at it. Right, so what we're saying is that she can buy more than 1 but no more than 4, and we're talking about the bracelets, right? The bracelets, and we know that Y is the number of bracelets. So based on that information, right, what we're saying is that Y, number of bracelets, has to be greater than 1, but the number of bracelets, which is Y, has to be less than or equal to 4. That is what we were told. And since this is a range, numbers greater than 1 but less than or equal to 4 actually falls in an interval, and we can represent an interval in inequality by combining those two inequalities, because you can be greater than 1 and less than or equal to 4 at the same time, right? So this inequality is saying that y is greater than 1, because inequality can be read from both directions. Y is greater than 1, y is greater than 1, but y is less than or equal to 4. So this really is our second inequality, as was outlined by our second condition. And then the third condition is that she also wishes to buy at least 3 earrings. At least 3 earrings means she wants 3 or more earrings. If you must have at least $2, it means that you must have $2 or more. So at least 3 earrings means at least 3 earrings means 3 or more earrings. So let's put that information in. So what we're saying, the third condition is that she wants at least 3 earrings, and that means she wants 3 or more earrings. So the number of earrings, which is x, has to be greater than or equal to 3. Right? Has to be greater than or equal to 3, and hence this is our third inequality. The number of earrings, which is x, has to be greater than or equal to 3. So those are our 3 inequalities: 1, 2, 3, and that's the answer for part 1. Now part 2 says we have to draw the graph of the inequalities using a scale of 2 centimeters to represent 1 unit on both axes. So basically we want to draw graphs representing this inequality, and this inequality. Now what we're going to do, we're going to look at them one at a time. So let's first look at what we would have to draw for the first inequality, right? And then we explain as we go along. So let's put in what we would have to draw for the first inequality, and then we're going to go ahead and draw the inequality. So what we're going to do in the meantime as well, we're going to bring the graph, bring the frame for the graph in, and then we go ahead and we draw the lines for the inequality. So that's the frame, and then we draw as we go along. Now what we're saying is that the first inequality is x plus y must be less than or equal to 8. Now what does that mean? For this inequality, what we're going to do, we're going to draw an unbroken line, x plus y equals 8, and we'll also be interested in the region below the line. Now the unbroken x plus y equals 8 line, it is drawn unbroken because the equal is a part of the inequality, and the unbroken line is to indicate that the line is a part of the required region. You see, this is equal, this is x plus y equal to 8 or less than 8. When we have the equal included as a part of our inequality, we draw an unbroken line, right? And then the less than sign in inequality, once the y is positive on the left hand side of our inequality, then the less than sign means that we want the region that is below the line, right? So this inequality means that we want the line x plus y equals 8, and we also want the region that is below the line. So because we want the line, we draw an unbroken line. Now this line x plus y equals 8 is the line that will pass through 0, 8 and 8, 0. It will cut the y-axis at 8, and it will cut the x-axis at 8. And the reason for that is that when x is equal to 0, as in this case, when x is equal to 0, y is going to be equal to 8, and so this line passes to the point 0, 8. And when our y value is 0, our x value is going to be equal to 8, and so the graph also passes to the point 8, 0. So we can go ahead and put that line in. Right, we can go ahead and put that line passing through 8 on the y-axis and 8 on the x-axis, and that's our line. Now this arrow below the line is to account for the region below the line. So we are saying that we want the line, so it is drawn unbroken, and we also want below the line. So the region that we are interested in so far is the region, the line, and below the line. So that's our first inequality. Now for the second inequality, our second inequality is this one, right? What is the meaning of this? Right, it's a combined an interval, but we can separate them because really it's two lines we have. We have the region where y is greater than 1, and we have the region where y is less than or equal to 4. So we're going to look at the y greater than 1 first. The y greater than 1 really means that we want above a broken line, and the broken line is going to be an horizontal line, y equals 1. Now the line for this y greater than 1, we draw a broken line to indicate that the line is not a part of the inequality because the equal is not there. The broken line is just now being used as a boundary for the y greater than 1. So because the equal is not there, we draw a broken line to indicate that we do not want the line itself to be a part of the inequality, and that only the region above the line we will want. And then we must also now observe that y equals 1 is a horizontal line because the x-axis is y equals 0, so y equals 1 is parallel to the x-axis and passes through 1. That is, y equals 1 is an horizontal line passing through 1, and because the equal is not there, we have to draw a broken line. So let's go ahead and put in our y equals 1. So that's our y equals 1. And then now this arrow above the line means that we want the region above the line. So we put arrow pointing up, right, to indicate that we want the greater than sign. Right, we want the region above the line. What we should also do is label our line. So let's label this line y equals 1, and you must label line with the equal sign because the line is the equal mark, and we can go back and label our x plus y equals 8. So that's our x plus y equals 8. You must label the line with the equal sign. Now we want the second part of this inequality, y less than or equal to 4. So this line is going to be an horizontal unbroken line, y equals 4, and we want below the line. So we draw the line unbroken because the equal is there, so the line will be a part of the inequality, and then the less than sign now is indicating that we want the region below the line. So we can go ahead and put in that horizontal line. Y equals 4 is an horizontal line passing through 4, so that is it. And the arrow pointing down is to indicate that we want the region below the line, and then we must label our line with the equal sign. So that line is y equals 4. Next, we want to deal with the third inequality, and the third inequality is x greater than or equal to 0. Now x greater than or equal to 0 means that we want a vertical broken line x equals 3 and above. Now x equals 3 is going to be a vertical line because the y-axis is x equals 0, and x equals 3 is going to be a vertical line passing through 3. It will be parallel to your y-axis, which is x equals 0, and it is drawn unbroken because equal is a part of this inequality. And then we also want above the line. Now above a vertical line means to the right of the line, right? So we can go ahead and put in the line x equals 3. So x equals 3 is a vertical line passing through 3. That's it. And then we want the region above the line. Above a vertical line means we want to the right of the line, because values on this side of the line will be greater than 3. And then again we label our line with the equal sign. So we label that line with the equal sign. Okay, so that basically takes care of the 3 inequalities. So we see that we want above this line, we want below this line, we want below this line, and we want above this line. So we can go ahead and do part 3, which is to indicate on the graph the region which satisfies the 3 inequalities. And we're going to indicate that region by shading that region there. So that region is a region that satisfies the 3 inequalities. Okay, now part 4 says determine the highest possible value of x and the corresponding value of y. Now when we want maximum and minimum values in a linear programming question, we normally go to the vertices of the required region. Right, so if we want the highest possible value of x, normally we would go to this point here. Let's call that point A. Right, so we normally would go to A, but what is happening at A is that A is a point on the broken line. And remember, we cannot accept values that are equal, that where y is equal to 1. Our y values must be greater than 1. We cannot accept points on the broken line. Remember, the broken line is not a part of the shape of the required region. So therefore, what we have to do is move along the side to find another valid point. Now we move along the side, we might end up at this point. We also cannot use this point, because this point we are talking about 6.5 earrings and we are talking about 1.5 bracelets. You cannot have 6.5 earrings. So you have to continue along the side till you find a valid point. Now this would be a valid point, because here you would have 6 earrings and 2 bracelets. So we can label that point. Let's call that point B, and that would be a valid point, and that is where we would have our highest value of x. So let's put that information in to cover what we have just said, and let's put it here. What we are saying is that vertex A is not acceptable because y has to be greater than 1, and also that point A is on a broken line. We cannot use points on a broken line, so we move along the side to point B. We cannot move along the broken line, so we must move along this side to point B, and B is a 0.62, and therefore the highest value of x is 6. X equals 6, and the corresponding y value right here is 2, and that's the answer for part 4. Now part 5 says we are determining the values of x and y, which will give the minimum amount spent and determine this minimum amount. Right, so the amount spent, remember she's spending $70 on each item, $70 on earrings and $70 on bracelets. So the amount she's going to spend is 70x plus 70y. And again, because we want minimum, we go to the vertices of the region. So normally what we would do, we would go to this vertex first. This is where we would normally attain our minimum, right? But because this point here is on a broken line, we cannot accept this point, and we therefore have to move along the side to the first valid point along the side. So let's label this point C, so we can make reference to it in our statement. And we said we cannot accept point C because it's on the broken line. We have to have y values greater than 1. So we move along the side to this point here. That's the first valid point we meet. right, after moving from C along the side. So let's call that point D. So that point we call D. So that's the point we have to use. And at D, what we observe is that at D, X is 3 and Y is 2. So this is the point that will allow the minimum amount to be spent. So we can go ahead and put in that statement. And what we are saying is that the vertex C is not acceptable because Y has to be greater than 1, and that point is on a broken line, and we cannot accept points on a broken line. And so we move along the side to point D. That's the first valid point along the side. We cannot use this point because that is talking about 2.5 bracelets. We cannot have 2.5 bracelets, so we can only have 2. So this is the first valid point. So that coordinates of point D is 3, 2. Right, 3, 2, and therefore the minimum amount is spent when X is 3 and Y is 2. So you plug those values in this equation here for the amount spent. So you get $70 times 3 plus $70 times 2, and that works out to $350. So the total amount spent is $350, and that's the solution for question 9b. Thanks for visiting Wizznotes.com. Come back again for more solutions in mathematics. Okay, bye.